screen as well. Okay, so if you can't see what I'm doing, just let me know. I haven't really used the Surface tablet too much before. So pretty much I wrote down what we went over before. So in example 2, we already filled out A, and more importantly was part B here, which said use the graphing tool to graph the equation. And so we knew that the function here was x squared. So naturally, we knew that the shape would be this cup shape. And so all we have to do is take that cup shape and fill in all of the information in the box here, and it would sketch the graph for us. So that's what we have. And now that we have the graph, I was talking about part C, and then I ran out of time, so I'll just go ahead and start over with C. So the way part C starts off is they want us to find points that lie on the graph of y is equal to x squared only. And there is a reason for why they're having us plug these values into x squared. So first, let's go ahead and do that. If we plug in -2 into x squared, we get +4. If we plug in 0 into x squared, we get 0 because 0 squared is 0. If we plug in 2, we get +4. And the reason why it's x squared is because that's the basic shape. That's the basic shape before we do any sort of transformation. And so after the transformation, they also want us to find the corresponding points, which tends to be a little bit tricky to determine all of that. So with the corresponding points, we would not be transferring the x values over. So we're not using -2, 0, and 2 here, but we need to see that since we are shifting to the right 3, remember we're shifting to the right 3 in this problem, then that means all of our x values will shift to the right 3, which means instead of -2 here, we shift that to the right 3. So -2 plus 3 is just 1. And then 0, shift that to the right 3. And 2, again, you shift that to the right 3, that's 5. And now they want you to plug all of those x values into the function up here. So if we plug in 1, let's see, that's going to be 13. If you plug in 3, that's just going to be, looks like 1. And if you plug in 5, that's going to be 13. So the corresponding points, you have to apply any sort of horizontal shift you may have to get those x values. So that's where the 1, the 3, and the 5 come from here. So how's everyone feel about that so far? If you have any questions, just go ahead and stop me.
Wait, where did the 13s come from? I blinked out for a second.
The 13s, they just came from whenever you plug 1 into this highlighted part. So if you plug in 1, 1 minus 3 is -2. -2 squared is +4. 4 times 3 is 12, and then 12 plus 1 is 13. So if you plug all that in the calculator with x is equal to 1, you get 13. Same thing with 5.
Okay, I got you. Thank you.
Yep. Where can we find? I feel like I've answered this several times. It's my math lab. I posted the workbook in my math lab. I'm not going to talk about it anymore. So let's go ahead and move on to the domain. And now that we have the graph, the domain and the range is fairly simple to figure out given the graph. So the domain is left to right, and it deals with the x values. So since we have the graph, there we go. Since we have the graph, then we see that the furthest to the left that we can go is over here, and the furthest to the right we can go is over here. I just highlighted both of those regions in red. And so it looks like, since we have arrows on the left and the right, it's safe to say that the domain is negative infinity to infinity for the domain. For the range will be, well, not all real numbers, because with the range, it's the lowest point to the highest point. In the lowest point, we do not get an arrow, but instead we get this value right here. And since we're dealing with the range, so what is that point right there? That point seems to be 3,1. So since we're dealing with the range, we want the y value. So we're going to pick the 1. And we're going to use a bracket because that 1 is assumed to be a part of the graph. There's no open circle there. And so additionally, that's the lowest point. So the highest point, we get positive infinity. And so that would conclude this problem, the process for this problem. Okay. Does anyone have any questions about this problem before I move on? Because if not, I'll go ahead and move on to the next stuff. So we talked about various shifts. I'll go ahead and leave this up while I talk about this. We talked about various shifts. So left, right, up and down. We talked about compression and stretching. There's only one more thing we need to refer to, and that's reflections. And reflections are, well, if you take some graph and you flip it in some way, that's a reflection. So you can either flip it across the y-axis or across the x-axis, as you can see below here. And so visually, I think we understand how this flip works. If you have some function up here and you want to flip about the x-axis, it would end up down here. And similarly for the y-axis. But how does that translate algebraically? And its algebraic translation is provided by the criteria below. So for the reflection about the x-axis, so if the whole function is multiplied by -1, if the whole function is multiplied by -1, or in other words, if y is multiplied by -1, then you would reflect about the x-axis. And with the y-axis, that is when, if the variable x alone is multiplied by -1. So that's sort of the distinction here, which we will see. You might be able to notice this in the next problem. So let's go ahead and just see what how all of that applies. So for problem 1, we're going to go ahead and figure out some criteria of this. Graph the given functions using shifting, compressing, stretching, all that stuff. Find the domain and range. So as you can see, it gives us the box. So naturally, we need to go ahead and find out all of those individual characteristics. And we'll go ahead and start off with problem 1 here. So if anything, what I notice from this problem, I see a plus 11 and I see a negative in front of the x. So let's go ahead and break that down, what all of these mean individually. Okay, so the plus 11 here, since the 11 is being added to the whole function, it means we're going up 11. Remember, up or down is a verbatim operation. So if it says plus 11, you go up 11. And so the way that would translate, this is the vertical shift. So it's the vertical shift, which would translate down here. There's no horizontal shift because there's no number being added to the x directly. So we don't have a horizontal shift. We can leave that one alone. There's no vertical stretch or compression. So really the vertical stretch or compression, it's just 1, which should be in there by default. And so now the question is, now there's that negative sign. And generally, when you multiply a negative sign, that's what will characterize a reflection of some sort. So I think we can all see that the negative sign is right there on the x. So what does that mean for the negative sign to be on the x? It seems like that one is a reflection about the y-axis. So we can just go ahead and write that down. Reflect about y-axis. So how that translates to this box down here, you might be able to notice it already. You would just check that box. So that's all you would do. You would mess around with the vertical shift to make it go up 11, and then you would check reflect over the y-axis. Before the box comes up, the only additional thing you would need to do is select the correct shape of the graph. And this is a square root graph. You see the square root in the problem. Now, I'll come back to this. The square root shape from the library of functions here that we talked about is number 5 here. So notice it's this arc shape. And that's the shape that we're going to utilize as we apply all of these transformations. So it says, take that arc shape. So on MyMathLab, you just select the arc shape, that square root of x or root function shape. But when you do that and you put in everything else for the box, what you will get so really my graph doesn't do it justice because my graph only goes up to 10. But perhaps let's make this a little bit easier for us. I'm going to change one very slight thing here. Let's just make that 11. Let's make it a 5 in the problem. So just scratch it out in your notes, make it a 5, so we can actually plot this thing. So the only thing that changes is that this goes up 5. So instead of 11. So we can actually plot this. Again, in MyMathLab, it'll do all of this for you. It'll have the spacing and the spanning all figured out for you. So if anything, that arc shape is now shifted up 5. So again, just change that in your notes to 5 from 11. That's all it changes. And additionally, when you reflect about the y-axis, instead of the arc going this way, the arc is going to go this way. So we reflect about the y-axis. And this is the shape you will get. Again, MyMathLab will simplify this process for you. I just wanted to visualize it here very explicitly. We still have to find the domain and the range, but does anyone have any questions so far about the identification of stuff on this graph? If not, then let's go ahead and find the domain and the range down here. So remember, the domain is left to right. I'll go ahead and use red. And also good news, I saw we got the cool monitor in the classroom. So I'll have a much better format of teaching. I can write on that one much better from what I was told. So, but anyway, the domain, it's left to right and it deals with x values. What's the furthest to the left we can go? I see an arrow. So that points towards negative infinity. What's the furthest to the right? It seems to be that point right there. And so what is that point? Seems to be 0, 5. But with the domain, we want only the x values, which is naturally why we pick 0. And we include 0, so we're using a bracket because that is part of the graph. The range, we look at lowest point to highest point. And we use y values. So the lowest point is this point again. And since range deals with y values, we're going to use the 5. And that is included because that point is included in the graph of the square root. The highest point is actually this arrow, which means we would look at positive infinity. And so that would actually answer this question right here. Having the graph is really convenient to help us determine some characteristics about the graph, such as the domain and the range. So that's why it's good to have a graph sometimes. So does anyone have any questions about that before we look at part 2 over here?
I have a question. Can you tell me again how you knew how to reflect over the y-axis?
It was simply by virtue of seeing that there was a negative sign in front of the x. So that's the only thing. So it's just an identification thing.
Okay, thank you.
Yep. So yeah, in general, if you see a negative sign multiplying anywhere, that's a pretty good indication that you're going to be reflecting in some way, as you might be able to foreshadow in part 2 here. So let's see, any questions there? No. Okay, so let's look at part 2 and get a little bit more practice because there's more stuff going on here. So we'll go ahead and start off the same way we did before by simply seeing what all we can determine here. And I'll use a few different colors to really distinguish them. So one thing I noticed, I see this -2 out here off to the side. Whenever we add or subtract, that means we're shifting in some way. We're going up, down, left, or right. We are subtracting 2 from the function as a whole because it's all the way on the outside by itself, which means up or down, which is a verbatim operation, which means subtracting 2 means we go down 2. And this is a vertical shift. It's a vertical shift because that's what it's called in that little table at the bottom. Another thing I see is this +4 here. Since the 4 is being added to the x directly, this means left or right. Left or right is an opposite operation, which means if we add 4, we have to go to the left 4, which is a horizontal shift. And finally, I do see that there is a minus sign multiplying in the very front here. So that minus sign. And so what does that tell us? Well, that minus sign is not multiplying the x directly. It's multiplying the function. And since it's multiplying the function, then that means we're going to reflect about the x-axis. So we're going to reflect about the x-axis. So I'm trying to remember, I think, all right, so there's a rule of thumb here, and I already had a question about it. So depending on the order in which you put all of these into that table down here, you might get a different answer based off of the order for which you do this in. And the reason why is because you don't want to reflect too quickly. If you reflect, if the first thing you do in this problem is you check off reflect over the x-axis, well, the graph will reflect and it might not shift properly. And so this is another way of saying that applying these works very similarly to the order of operations. And so instead of having to memorize a bunch of lame rules, well, primarily, so I'm trying to remember if you reflect first or you reflect last, because doing one of those will definitely help you out over the other. So if you go down to, I mean, I can kind of derive it myself, but there is an order for which you do this in. So let's see, if you go to the left 4, you reflect about the x-axis, which means you would stay here, and then you go down 2. All right, so you want to reflect first. That's what you want to do. You want to reflect first. So that's kind of the rule of thumb here. So and it's more so just a MyMathLab nitpick thing. If you reflect first, so you just come down here and you check off reflect over the x-axis first, that should take care of it. I'm pretty sure that is, again, let's see, just to make sure, you would shift to the left 4, then you would reflect about the x-axis. So that means you would stay here and then you would go down 2. But if you went left and then down and then reflected, that'd be wrong. So that has to be it. So you reflect first. So this little rule down here. So all that means is if you reflect in one of these problems and you have to use this table, just go ahead and check off any reflections first and then put everything else in. And this does matter. I've had questions about this one before. So with all of that out of the way, you put in the reflection first, then either vertical or horizontal in any order. Everything else can follow in whatever order you want. And you also have to pick what the shape of this looks like. Now I see x to the 3rd here. So I see x to the third, or a third power, in other words. And so that's the snake shape. That's the snake shape. So naturally, with that snake shape, where it will place this graph is it will pretty much center that snake shape here whenever it starts to kind of do this slight curvature. And since it reflects about the x-axis, it's going to actually flip as such. We're used to the snake shape going from down to up, but since we reflect about the x-axis, it's going to go up to down. So again, this is stuff that my math lab will take care of for you, but I'm just showing you how I derive it here for you all. So all you'd have to do is just click reflect, take care of vertical and horizontal, click the snake shape, and all of what I said is done for you. And so does anyone have any questions from here before we find the domain and the range?
I have a question for you, sir.
Yes.
Where did you get, and I could have just missed this or could just be confusing myself, so just if you could explain it real quick, that'd be awesome. But how did you get to the point -4, -2? Did you just like solve the equation? And is the vertical stretch always going to be 1 in the box?
So -4, -2 came from down 2 and left 4.
Got it. Okay.
Yeah, so that's where that came from. And the reason why the vertical stretch is just 1 is because we're not multiplying the function by a number that's bigger than 1. So the best way to really show this is, so notice the function is being multiplied by really -1. And so that's in contrast to, say, this problem where the function was being multiplied by a number bigger than 1 here, 3. So that's why we put a 3. So we had an example where we've had a vertical stretch or compression, but since we do not have such a number, it just so happens that both of those examples do not have a number multiplying the function. And so that's what you have to look for the stretch or compression.
Okay, thank you so much.
Yep. And so let's go ahead and find the domain and the range as well. So you might already notice that the domain and the range are both going to be all real numbers, -infinity to +infinity. And the reason why is because when we look left to right, you may notice it's all arrows. That's the leftmost. This is the rightmost. It's all arrows. So -infinity, +infinity. If you look up and down, same thing. You get arrows again. And those arrows, as you could tell, are very nice. They're very helpful. So that's all we need to do to conclude that problem. So any questions before I move on? So I guess while you all are still writing this down, for those of you, I noticed there's been a few of you coming into the session a little bit later. But so to catch up with the hurricane stuff, the department wanted me to make a video and give it to you all for you to watch, and you'd have to watch it on your own. I'm not very happy about it, but I did. So after this lecture and you do the homework for this section, which is due, I believe, tomorrow, you will also have to go and watch this video on your own and finish the homework for Monday. Now, to make up for that, Monday, I wanted to make my office hours just a homework review session. I'll just be in there on Monday because the homework for that video is due Monday night. So I figure I'll just make my office hours just a homework review session, and I'll just do problems. Or if you have any requests, I'll do those. Because again, I'm not too thrilled about it, but this is the situation we have to be in. I'll try and compensate. So I'll have those videos that I pre-recorded. I'll have those up there. They were processing right before I started this video in YouTube. So I'll be putting up all the links. The link for this video and the video for quadratic functions and graphs. All of that, I'll put all that up at the same time in the lecture links tab. So that's the unfortunate situation of the results of the hurricane cancellation. And so, but yeah, I'll make my Monday office hours homework review sessions. And if you're interested in that, just let me know. But we have 2 more problems. Starting off with example 4 here. And this requires us to graph an absolute value function using the techniques of shifting, compressing, stretching, blah, blah, blah. Now, honestly, I don't really like this problem because it doesn't follow the traditional flow of the other problems, in the sense of it doesn't give you that box and you fill in horizontal, or you move the slider around for the vertical shift, the horizontal shift. What this problem does is, after you pick the shape of the graph, which we'll talk about in a second, you have to find 2 points on that graph. It's not going to be anything about shifting. You're finding 2 points on the graph. And the first one has to be something called the vertex. So with that being said, so let's figure out the shape first. So I'm not going to explain this. This is one problem on your homework that tends to confuse students. And so I'm just telling you how to do it. In other words, I'm just telling you how to do it. I'd say just don't really worry about this one. So let's figure out what the absolute value shape looks like. So the shape, the absolute value shape, which we really don't talk about too often, which is another reason why I just want us to get past this one. It's this V shape. So it's a V shape. So if anything, we have an idea of what shape to pick on this graph. So if you interact with the graph and it asks you for the corresponding shape, you would pick the V shape. So if anything, is the shape, it's a V shape. But as I mentioned, it's going to ask you to find 2 points instead of giving you that table of stuff to fill in. And the first point has to be the vertex. Now you'll learn about the vertex in that video that I pre-recorded, and you have to watch on your own. You'll learn about what it is there. But here, and just in general, the vertex is just wherever the point, it's the point for which the function kind of grows out of. We tend to see this with the cup shape as well. There's a minimum and a maximum. That's the vertex. And for the V shape, the vertex is just pretty much that lowest point, or that highest point. So we need to find that point. And so the way we find that point, what I generally think of is, well, what value would give us 0 for this graph up here? So what value? I see x is equal to 1. So when we plug in x equals to 1, so 1 minus 1, of course, is 0. The absolute value of 0 is 0. And then 3 times 0 is 0. So if anything, that tells us that when we plug in 1 for x, we get 0 for y, and that is our vertex. So with that being said, so we found the vertex. And from what I noticed, you will get a very similar problem to this. Again, I just want you to do this problem and move on to something else. All we have to do is find any other point on this thing. Any other point. So we picked x is equal to 1. So just pick x is equal to 2. Just pick the next point to the right. So we picked x is equal to 1 last time, so let's just go up 1. We just want to find a point really close to the original one. So I'm going to pick x is equal to 2 and see what we get there. So 1 minus 2, in fact, I'll just write this one out a little bit more explicitly just in case. 1 minus 2, so now this is 3 times the absolute value of negative 1, because of course 1 minus 2. But what does the absolute value do? Just makes whatever's inside of it positive. So negative 1 would become positive 1. And then positive 1 times 3. Just 3. So when we plug in 2, we get 3. And now we have a second point. And by doing all of this, the graph will be generated for us. So again, it's not a very fun problem because you don't really, the shifting here is kind of ambiguous in a sense. It's a little bit trickier than you think because of how the numbers are placed. So this is the easiest way in which I could think about doing this problem. But again, this is just one of those problems I want you to just get out of the way and knock it out and don't worry about it. So we are not done yet because we just have to find the domain and the range, and then we're done. The domain is left to right, and it deals with the x values. The furthest to the left is this arrow, and the furthest to the right is this arrow. Naturally, that's all real numbers. The range starts at this lowest point here, where that point is 1, 0. So that was the first point we found. But the range wants the y value. So naturally, we choose 0. And 0 is included because it is a part of the graph. So that's why I'm using a bracket. And the highest up we go, we hit some arrows. So that is example 4. Does anyone have any questions about this one? Or can you recreate these steps to solve the one problem that they give you like this, in other words? So the video is going to be uploaded. You can see the REC button in the top left. That always lets you know that everything's being recorded. Or I don't know if it shows up on your end. It shows up on my end, but it is being recorded. So, and I'm going to publish this. So, with that being said, if there's no questions about this one, I'm going to move on to example 5, which I've already gotten a few emails about. Example 5 is, so this is a fairly popular question. So it wants you to build the function step by step. And in fact, what I want to do, I feel as though I want to change up these, I feel as though there's a more complicated situation that comes up that I want to address, because I've gotten a few questions about one problem in particular. So what was that problem? Was it? I'm pretty sure I know it. I'd rather do problems that are more pertinent to the homework. So I think I want to change a few of these. So A, scratch that out, and we're going to say shift up, say 4 units. So I'm just making a new problem here. And then it was reflect about, which axis was it? The x-axis. So just a new problem, because I've been asked a few questions about this type of problem. It's almost exactly similar to this. Yours might be shift down, but it'll follow it up with reflect about the x and then reflect about the y. So what I normally like to do, so we're going to do this one by one. And so when we shift up 4 units, so the function we're starting off with is the square root of x. So what does that become after we shift up 4 units? Well, hopefully you're starting to get the hang of these by now. It's when you add 4 to the function as a whole. So that would be the shift up of 4 units. So that's it for at least satisfying that criteria. And then from here, it wants you to reflect about the x-axis. So all of this is 3 steps they want you to apply to the same, so to the function, the original function you're given. So we're going to take that square root of x plus 4, and now from here, they're telling us now we want you to take that and reflect about the x-axis. Now the criteria from a few pages ago, a page or two ago, says to reflect about the x-axis, you make the whole function negative. What a lot of people tend to do is they will say, all right, make the whole function negative. And they will write exactly this. That is wrong. That's where I get a lot of questions. And I'll probably get a few more emails about this one for this exact reason. But this is not making the whole function negative. This is just making the first term negative. To make the whole function negative, this is the important part. You have to add parentheses around it. That's the part you're missing if you're getting this problem wrong, provided you do everything else right. You have to put the parentheses, so then you distribute the negative sign. And the question I normally get is, well, doesn't this mean, since now we're subtracting 4, doesn't that mean that we're going down 4? The answer is actually yes, it does mean that, because if you shift up, so here's the x-axis, if you shift up 4 and you reflect about the x-axis, then guess what? Now you're down 4. So this makes sense. If they give you the order, then that's just the process you have to follow. But that is the reasoning behind it. And if you ask me this question, I'll probably just send the same copy and paste answer and just change the numbers around. It's definitely it's a complex question, no doubt. It's a little tricky there, but that's pretty much the reason why. And so when we reflect about the y-axis, so what we had before was negative square root of x minus 4. How do we reflect about the y-axis? Well, the criteria for that is that you make x negative x. So that's what we did. I just turned x into negative x, and now we're done. Finally, to conclude, well, before I finish this problem, does anyone have any questions up to this point? If not, let's go ahead and conclude this problem with finding the domain and the range. So we don't really have a graph, so we need to at least visualize a graph. Some rough sketch of the graph. And since this is the square root of x, well, then we know it has that arc shape. And so what it's saying is take that arc shape, shift it up, reflect about the x-axis, and reflect about the y-axis. So if we were to shift up 1, 2, 3, 4, and the arc would start here, then it says, all right, forget that. We're going to go down 4 instead. To shift about the x-axis, and then to shift about the y-axis, the arc will now be going this way. If anything, there's you can use a graphing utility online to visualize this if you need to. So this would be after all of the reflections. And from here, we can figure out the domain and the range. Now the point here is 0, negative 4. So we'll utilize that. Since I'm about out of time, I'm just going to go ahead and write down that the domain is negative infinity to 0, and that the range is negative infinity to negative 4. If you have any questions about that, you can stick around. I will be uploading this lecture to YouTube, as well as the lecture you have to watch on your own for Monday's homework as well. So the homework for this is due tomorrow. The homework for that video you have to watch on your own is due Monday, and I'm going to have a homework session on Monday. I'll send out more information on that probably as I get requests for doing that. But other than that, and the workbook page is due tonight. Workbook page is due tonight. I've sent out several emails about, and especially my most recent email, class email, about what that pertains to. So please read that to get an idea of what is due tonight at midnight. So other than that, that's all I have for today, unless you want to stick around for me to help you with any homework questions you may have or any questions in general.